So sometimes the stuff that I write helps me give a wonderful lecture, and sometimes I just can't lecture with the material that I've written, and that's the case here. I've done this video 3 times today, and each lecture has gotten progressively worse. So I'm going to try to lecture without my handout, or at least not with all of my handout. This is going to turn into a 3-part video. I've already done parts 2 and 3, and they're not horrible. As we go through this video, this sheet of factors, which is available if you opened up the problems from section 5.3, might come in handy because you need to know factors of numbers really well. In section 5.3, ultimately we're going to factor trinomials that all have the same form or that can be turned into the same form. Each of the problems that we're going to have to factor is going to have an x squared term, an x to the first power term, and a constant separated by either plus signs or minus signs. So these are going to be typical of the problems that we're going to be asked to factor today. Each of the problems is going to be a trinomial, and what they're going to have in common in the first part of this video is there's going to be an implied 1 times a second power term, and then plus or minus, depending on what the problem is. The sign's not important, but there's going to be either a plus sign or a minus sign between the first and the second term. And the second term is going to be a coefficient times a first power term. Coefficient could be a negative or positive, but it's going to precede a first power term, and then either plus or minus some constant term. In the world of these problems, the numbers that are going to be most important are the constant term and the coefficient of the first power term. It's very common when a problem is written as a trinomial in this form, a second power term plus a or minus a first power term plus or minus a constant. It's very common to assign letter names to the coefficient of the first power term, and it's very common to assign a letter name to the constant term. We'll give B the coefficient of the first power term, and C the name of the constant. So those variables I'll be using consistently. When we get a little bit deeper into the chapter, the coefficient of the squared term, which is an implied 1 in each of the problems I'm going to do in this video, is usually assigned the letter A. So each of the problems that we're going to be asked to factor starts as a trinomial. We're going to factor it into the product of 2 binomials, and when we factor it in this first video, we're going to start with a problem that's a trinomial. We're going to cleverly or very carefully rewrite it as a problem that has 4 terms, and then we're going to factor by grouping. Let me try to jump into how we're going to do this real quickly without using my sheet that just is fighting the heck out of me. So I'm going to start off, and I'm going to attempt to factor number 2, which is asking me to factor x squared plus 7x plus 6. You may know how to factor this already. I can sight factor, meaning I can look at the problem and know how it factors without writing anything down but the answer. That I'll try to show you in the second part of the video. But for now, the technique I'm going to teach you will relate section 5.3 to section 5.2, which is nice, and it's going to relate section 5.3 to 5.4. It's an important technique because the technique I'm about to teach is going to help us in 5.4. So don't skip over this video, even if you know how to do these problems already. Just plow through it. So first I'm going to do is I'm going to identify the C. Actually, I'm going to identify the B and the C. In this problem, the B is the coefficient of the x term, which is 7. The c is the 6. What I need to do is I need to first find the factors of c with the signs from the template, which means find the numbers that multiply out to be 6 with the appropriate signs. It turns out that if I didn't have the template, then signs get to be a real issue. The numbers that I can think of that multiply out to be positive 6 are 1 and 6, 2 and 3, -1 and -6, -2 and -3. So those are all candidates for multiplying to 6. In this particular problem, because the original problem, the signs in the original problem are both pluses, when I go to find the factors of 6, I only want the double plus factors. I don't want to worry about the double minus factors. Even though two negatives can multiply out to be a positive, they're not going to be helpful in this problem. So I'm just going to write the factors of 6 with the appropriate signs, which are 1 and 6 and 2 and 3. That's how I use the c, the constant part of this. After I find the factors, I'm going to add them up. I'm going to add them up and find the pair that add up to b. So I'm going to find the pair of these that when I add them, instead of multiply them, that add to 7. So I'm going to add the 1 and 6. I'm going to add the 2 and 3. They both can't add to 7, otherwise this would be a disaster. Well, the 1 and the 6 add to 7. That's a good business. So I looked at the c, found the numbers that multiplied out to be c using the signs from my template, done with that step. Then I'm adding the numbers. I'm searching for the pair that add to b. Once I find the pair that add to b, I'm going to rewrite the middle term using these numbers. The middle term in the problem is the 7x. So the 7x in the problem, it's dead center between the x squared and the 6. I'm going to rewrite it as 1x plus 6x. This is all my preliminary work that I need to get started. I need to come up with a clever way to change the problem that I've been presented with 3 terms, and I'm going to rewrite it cleverly with 4 terms. And now I know the clever way to do this. I'm going to rewrite the problem x squared plus 7x plus 6, which is a problem that you may or may not know how to factor, but I can transform it into a problem that I should know how to factor because of what we did in the last section. So I'm going to rewrite the problem as x squared plus 1x plus 6x plus 6. If I simplified this problem, it would absolutely equal the line above it. Now that I have the problem rewritten with 4 terms, I know a technique for factoring problems with 4 terms. I split it into groups of 2. And after I get the problem split into groups of 2, I do 2 sets of common factor factoring. From my first pair, x squared plus 1x, I'm going to pull out a common factor of an x and be left with an x plus 1. Across the vertical bar, I'm going to pull out a common factor of a 6 and be left with another x plus 1. Now I have something that I can call an answer, or something I could turn into an answer by writing the common factor followed by the x and the 6 that are in front of the common factor. And of course, anytime I factor, the order that I write my factors in is just a matter of preference. There isn't any right or wrong way to write the binomials. I claim that this is the answer. I'll go ahead and check this just to show you that it's right. Checking takes a long time, and this video is going to be a half hour regardless. And I want to get bulks of problems done, and I'm going to skip on the checking. So how do I check? I check by foiling. And my foiling needs to simplify to the original problem. So let me foil. I'll do firsts are x times x. That's x squared. I'll do the outers, that's x times 1. I'm going to write plus 1x. I'm going to do the inners, which is 6 times x. I'm going to write that as plus 6x. And the lasts, I'm going to write as 6 times 1, which is plus 6. The outers and the inners generally combine when you FOIL, and that's the case here. The outers and the inners, the 1x plus 6x will add up to 7x, and I'll magically get a good answer. I'm only going to do one problem per sheet because I have 20 minutes left to get done as far as I want to get, and doing every even problem on the sheet is going to bog me down. So let me skip through, and I'll pick the problem on the second sheet that looks like that looks harder, and that looks like 8 looks harder to me. So for 8, I'm going to factor y squared minus 4y plus 4. I'm going to start off and I'm going to identify the b and the c. The b is the number in front of the first power term. This is the number that I need to add to. The c is the constant. This is the number I need to multiply to with the correct signs. So the very first step is to work with the c and work with my template. The signs in this problem are minus first and plus second. That's the second row of my template. That tells me the factors of c that I need are both going to be minus. So I'm going to start down writing down the double negative factors of 4. So I need the double minus factors of 4. So I need numbers that multiply out to be 4. Both have to be negative. Negative 1 times negative 4, they're both negative. They multiply to be positive 4. Negative 2 times negative 2, both negative. They multiply out to be 4. So I'm done working with my c. Now I'm going to work on to my b. What do I do with my b? I take the numbers that I created, the double negative numbers that multiplied out to be c, and I start adding them. I'm going to add negative 1 and negative 4. I'm going to add negative 2 and negative 2. My c was positive 4. My b is negative 4. These numbers multiply both to positive 4. These sets of numbers, when I add them, they're not going to both add to negative 4. Only one pair is going to add to negative 4, and that's the pair that I'm going to use on my next step. So first I work with my c in my template. I list all the numbers that multiply out to c with the appropriate signs. Then from that group of numbers, I add them, find the set that adds up to the middle number b. And now I'm going to go in my rewrite. The negative 4y, I'm going to rewrite my middle term. The middle term in this problem is the negative 4y. I'm going to rewrite the middle term using the negative 2's. Very specifically, I'm just going to write negative 2y, just keep negative 2y minus 2y. Keep the signs kind of with the 2y's rather than introducing. I could have written negative 2y plus negative 2y, but that is equal to that, and this is better. So now I know how to rewrite the middle term. I'm going to now rewrite the original problem with 4 terms in factor by grouping. So the original problem is y squared minus 4y plus 4. I'm going to rewrite it as y squared minus 2y minus 2y plus 4. Now I'm set up with something that has 4 terms, and they're 4 very carefully constructed terms, which means I can split into halves and do double common factor factoring. To the right of that vertical bar, I have to factor out a negative and change some signs. To the left of the vertical bar, there's just a common factor of a y. When I factor out a y, To the left of the vertical bar, I'm just left with a y minus 2. To the right of the vertical bar, I have to factor out a negative because that 2y has a negative in front of it. I need to factor out a 2 because that's the largest number that goes into 2 and 4. When I factor out that negative 2, I need to flip my signs and divide by 2. So the negative sign that was in front of the 2y is going to flip to an implied positive. The 2 that's in front of the 2y, I'm going to divide by 2. It's going to turn into an implied 1. And I'm just going to have a y leading off my parentheses. The plus sign that was in front of the 4 is going to flip to negative because I factored out a negative. The 4, I'm going to divide it by 2, and it's going to turn into a 2. So I get double duplicates here. I'm going to get a y minus 2, which is a common parentheses, in one of my parentheses in my answer. And then the y in the minus 2 that's in front of the parentheses as the other part of my answer. This would be an acceptable answer for number 8, but it can be written more efficiently. Anytime you get two identical factors, you could write the factor once with an exponent of 2. I feel like this isn't as bad as my last video. Hopefully it doesn't feel horrible to you because it's kind of going to be what it is. So let me just keep beating this to death and see how we can deal with this. Let's work with number 10. And in number 10, I'm going to start off, I'm going to say identify the b. The b is the number I need to multiply to. I'm going to identify the c. The c is the number I need to multiply to, and that's what I usually deal with first. And then I'm going to identify the b. That's the number I need to add to. So c is the constant here in problem 10. b is the number in front of the first power term. Let me dig out my template here. And since the original problem was plus and plus, on this first step, I'm looking for double positive factors of 36. I'm going to write them down, but you don't really have to write them down. But just because not everybody can do math in their head, I'm writing down double positive numbers that multiply to 36. I'm stealing them from my factor sheet. You don't have to have these memorized. You can use these on the test, this sheet on the test if you need it. So first step, I noticed my template said I need double positive factors and they have to multiply out to be c. Those are all the double positive factors that multiply out to be c. Done with my first step, done with the c, move on to the b. The b is 15. Now I'm going to start adding these factors that I figured out on my first step. And once I get to a pair that adds up to 15, I'm going to stop because I have the pair that I need. So I quickly got to the pair that I need. And now I'm going to rewrite the 15z in the problem using those two numbers. And when I rewrite it, the order that I rewrite it in is not a deal breaker. I could have the 3 first and the 12 second, or I could have the 12 first and the 3 second. Turns out that the order that you write the numbers in absolutely doesn't matter. Addition is commutative. If you are working along with me and you flip-flop the order, it's shocking how different the work looks. You'll never be able to follow my work, but you'll still get to the right answer if you don't make a mistake. But if you're following along, just do the order that I do and it'll be easier to follow. So now I know how to take the problem that I was given, the z squared plus 15z plus 36. Now I have a way to rewrite this with 4 terms, and 4 terms that are carefully constructed enough that the problem will factor successfully by grouping. So I'm splitting the problem with 3 terms into 4 terms, and I'm going to common factor each of the 2 terms on either side of my vertical bar. The z squared plus 3z, I'm going to pull out a common factor of a z and be left with a z plus 3. I'm just going to drag the plus sign down. That sign needs to stay, and I'm not factoring out a negative. Between 12z and 36, I'm going to factor out a 12 and be left with another z plus 3. So I'm doing GCF factoring in my head, which is something you need to really work on. If you can't do the GCF factoring in your head, pause the video and try to do the GCF factoring however you need to do it, like showing the division that I might have shown in section 5.1. And if you can't do the GCF factoring real comfortably, you need to go back and do section 5.1 again, because it's a hugely important skill that you need to get to the point where you can do GCF factoring kind of effortlessly, almost without thinking. Once I do my double GCF factorings, I'm in a place now where I can write my answer. I write the common factor in one of my parentheses and what's in front of the common factors in the opposite parentheses in my answer, and the order that we write our answers in is irrelevant. You have your complete freedom as to what you write first and what you write second. Let's do 15, which I think, well, let's do 16, which I think is harder than 14, because the double negative, I think, are the hardest signs to factor with. So I'm going to rewrite 16 so I can emphasize what the C is and what the B is. In 16, the C is the negative 6, the B is the negative 1. I look to my template. This is the very bottom row of my template. So the numbers that I'm going to need to multiply out to be C needs one positive and one negative, smaller number positive. So on my first step, I identify the C. I look to my template, tells me I need 1 plus, 1 minus. They have to multiply to negative 6. The smaller number needs to be positive. So my choices are going to be 1 and negative 6. Those 1 positive, 1 negative, smaller number positive multiply out to be negative 6. Similarly, 2 and negative 3 also fit the bill. They fit the multiply to negative 6, smaller number positive. Done with kind of my first step. Now let me add these numbers up and see if I can get the pair that I need. 1 plus negative 6 adds to negative 5. That's not the pair that I need. 2 plus negative 3 adds to negative 1. That's the pair that I need. And when I go to do my next step, when I go to rewrite the negative 1x, if there's a positive and a negative, I always do the negative first and the positive second. I needed to rewrite the negative 1x using the 2 and the negative 3. It's going to make my work a million times easier for me if I have a positive and a negative from that middle step to do the negative first and the positive second, because it'll make it so I don't have to factor out a negative. So now I know how to rewrite the original problem so that I can factor by grouping and get to my answer properly. So I rewrote the negative 1x as negative 3x plus 2x and put my vertical bar in. I have a left half and a right half that I need to common factor. For the x squared minus 3x, I'm going to factor out a common factor of an x and be left with an x minus 3. Across the vertical bar, I'm going to factor out a 2 and be left with an x minus 3. Again, that's the kind of factoring that just needs to be second nature, so I'm not explaining it so much at all. But you need to be able to understand what I'm doing. Visit me in class, or if we're in COVID times, shoot me email and we can do like a Zoom lecture, and I'll try to help you through any issues you might be having to get you over the hump of factoring out the common factor more efficiently. On this page I'll do 18 just because I don't think we've done this sign combination yet. 18, if I want to emphasize the b, I could write it as x squared plus 1x minus 12. And in this problem, the c is negative 12, the b is 1. I look at the number negative 12 and the signs, and because the signs in this problem are plus first and minus second, When I find the numbers that multiply out to negative 12, I need one of them positive, the other negative, the larger number is positive. So I'm going to pull off the factors of 12 from this sheet. One positive, one negative, larger number positive, smaller number negative, and use those for my first step. The numbers that multiply out to negative 12 that satisfy larger number positive, one of them negative, are those three numbers. I took the factors of 12 and put the signs in that I needed. And now I'm going to start adding them, and once I get to 1, I'm going to be good. The 12 plus negative 1 is 11. That's no good. The 6 plus negative 2 is 4. That's no good. The 4 plus negative 3 is 1. That's good. So first step, give me the candidates to combine to get B. Second step, actually find those candidates. And now I'm going to rewrite the 1x, which is the middle term, using the negative 3 and the positive 4. Always, if I have a positive and a negative, I put the negative first and the positive second. And now I know everything that I can possibly know other than the how to actually do the common factoring for the grouping. So I'm going to rewrite the problem with the 1x separated into negative 3x plus 4x. Created my problem with 4 terms, and now I'm going to factor by grouping. My first pair, I'm going to pull out a common factor of an x and be left with an x minus 3. First factor being of x squared minus 3x, I factor out an x, and I'm left with an x minus 3. The second factoring of 4x minus 12, I factor out a 4, and I'm left with an x minus 3. And that allows me to write an answer in 2 separate ways, either x minus 3 times x plus 4, or equally correct, x plus 4 times x minus 3. It turns out that if you can get these steps nailed, that the next part of the video is simple. It's just really just finding these is the whole key to all factoring. All right, on this sheet, it looks like 24 is harder, so let me try 24, which is asking me to factor x squared minus 5x plus 2. In this case, my c is 2, my b is negative 5. My template's going to help me out here. My template says if the original problem starts with a minus and then it has a plus, I need double negative factors. So my first step, I'm going to write the double negative factors, the numbers that are both minus, that multiply out to be positive 2. Since 2 is a prime number, I have really limited choices. Negative 1 times negative 2 are the only numbers that are double negative that multiply out to positive 2. So let me go down to the next step and start adding these up. Negative 1 plus negative 2 adds to negative 3. I don't have any more choices, and I'm trying to get a negative 5. My goal is to always get that b. Because I can't find a pair of numbers that do the requirements, double negative numbers that multiply to 2, that also add to negative 5, this thing cannot be factored. In fact, if I just randomly create a trinomial, the chances that it can be factored are actually pretty slim. I actually have to think before I write down a trinomial to make it factor. And because this can't be factored, the answer that we generally write when we can't find pairs of numbers that need to do what they have to do, we usually write prime down. One more will be over 30 minutes, which I'll have to live with, and we'll move on to a part 2, then a part 3. I'll work with 26. I'm going to attempt to factor y squared plus 2y minus 11. The c is a minus 11. The b is a 2. My template tells me, since the original problem has a plus sign followed by a minus sign, that the factors of c that I need 1 plus and 1 minus, larger number positive. I'm not going to have a heck of a lot of choices because 11 is a prime number. So my choices for the C, larger number positive, smaller number negative, are 11 and negative 1. Those multiply out to be negative 11. Now I'll move on to my next step and I'll start adding these. 11 plus negative 1 adds up to 10. Unfortunately, just like in the last problem, I can't find a pair of numbers, bigger number plus, smaller number minus, that multiply to negative 11 that also add to 10. So this also cannot be factored. And if I can't find a pair of numbers that simultaneously do both things that they need to do, we call the polynomial prime. In the next part of the video, we'll learn how to quickly get the answer and we'll learn how to avoid doing grouping, but the grouping is going to be important because it's a skill that you're going to need in 5-4. So let me pause the video and then we can move on to part 2.